So, namaste everyone. Today we'll derive the equation of motion by graphical method for constant acceleration. First, let us see the derivation of s is equal to ut plus half at square in easy method. It's very easy method. So let's see here. We'll make a graph. There is a vt graph. We'll make velocity on the y-axis and time on the x-axis. So as you can see here, we'll draw a line AB and join the B to D down point. We see that BD is V, final velocity, and OA is nothing but U, and OD is obviously time as it is velocity time graph, and BC will be V minus U because you can see here AO is U and BD is V, then BC will obviously be V minus U. So let's start deriving. What is the displacement exactly mean by this graph? By this graph, the displacement exactly means that area under AB. Okay, let's start it. Area of rectangle OACD plus area of triangle ABC. Is it right? Yeah. OACD of, see here, nothing but OACD plus the area of A, B and C. So what we get here, area of the rectangle OACD, that area of the rectangle is, you know, that length into breadth. This is length, this is breadth, length into breadth. We get UT plus half V minus U into T. What is V minus U? This BC is nothing but V minus U. T is AC. AC is time, as OA equals AC because it's a property of rectangle. You know that already. So we get an equation like this: ut plus half V minus U into T. The next step is a magical step, friends. Ut plus half V minus U, we multiply and divide by T. We multiply and divide by T. So what we get here, ut plus half V minus U by T into T square. You can see this thing, can you identify this thing? V minus U by T is nothing but acceleration, is nothing but the acceleration. So instead of V minus U by T, we'll substitute A, right? So we get the equation, final equation, ut plus half at square, that is distance is equal to ut plus half at square finally. So let's see the next equation, that is to prove v is equal to u plus at. Okay, so acceleration of the slope AB, acceleration is the slope of AB. So what the slope you are seeing here is nothing but the acceleration. So A is equal to V minus U by T. Nothing but A is equal to BC by AC. What is BC? BC by AC. Nothing but tan theta, guys. It's tan theta. AB, the slope is nothing but the acceleration. So what is tan theta of this? Nothing but BC by AC. BC, we know that it is V minus U. And AC is the time. Great. A is equal to V minus U by T. We got it. T will send this side, it will become AT, and U we are sending here. It will become, on rearranging, V is equal to U plus AT. Hence, the second equation is derived. Let's see on the third equation. V square is equal to U square plus 2AS. So proof, we know that V is equal to U plus AT from the previous equation, right? We'll square on both sides here. We'll square on both sides. V square will keep as it is, and U plus AT whole square. What we get? U square plus A square T square plus 2U AT. What is this? This is nothing but the expansion of A plus B whole square, right? U square plus A square T square plus 2A I am writing separately, and UT I am writing separately. Nothing will happen, right? what will happen? I will write these two together and these two together. Nothing changed, just rearranging in this last term. Let's see what magic happens here now. We know that s is equal to ut plus half at square, right? Now if we send this half at square here, we will get ut, right? If we send this half at square here, we will get ut. Let's name it as equation 1, right? So we are substituting in this equation 1 in the previous equation. V square is equal to u square plus a square t square plus 2a into s minus half at square. Instead of ut, I am writing s minus half at square. So we multiply this 2a inside here. What do we get? V square is equal to u square plus a square t square plus 2as. Here 2 get cancelled. Finally we get a square t square minus a square t square. So minus a square t square get cancelled and plus a square t square get cancelled. We finally get v square is equal to u square plus 2as. Here we proved it in my method. So happy to say that. Thank you guys.